Okay, so on this video, we're going to look at the arguments. So essentially, the whole chapter of the logic chapter is getting you to the arguments section. And so the arguments is basically, we have these simple statements that are combined somehow, and we're trying to make some argument. And so the generic setup is always the same for the argument. So the argument is always going to be a premise, and it could be as many premises as possible. 3 dots, which means therefore, and then your conclusion. So you have a premise, and a conclusion. Now, mind you, there could be more than 2 premises. But for this particular course, we're only going to see 2 premises just to get us started, okay? So an argument, do these premises validate this conclusion? Essentially is what you're doing. And you're going to use a truth table to identify whether the argument is valid or not. And validity just means that everything comes out true. So valid means that when you do your truth table, everything comes out as a true statement. Everything comes out for your final answer. Everything is true. That means it's valid. Otherwise, it's going to be invalid. So if you don't get all true, then it's automatically invalid. So you also have the setup of the argument. So the setup of the argument is always the same. So the argument is always set up as premise 1 and premise 2. And remember, it can be as many premises as allowed in the problem. Therefore, your conclusion. So all arguments end up being conditional statements, essentially. All arguments end up being conditional statements. So we're going to translate these 2 examples, 16 and 17, and then I'm going to do the truth tables to show you how to determine validity. So we start with 16, and what we're going to do is, what you should do is you should just go through and identify your own P and Q. So I will order pizza. I'm going to make that P. Or Chinese food, which is Q. So I will order pizza or Chinese food is my first premise. My second premise, I did not order Chinese food. So that means not Q. Therefore, I ordered pizza. So therefore, P. Okay, so that is how I translated my words into my symbols. And then I can write it as the conditional statement. So it would look like P or Q and not Q. Therefore, P. So that would be the conditional statement of that argument. And so from there, I would be able to do the truth table. Okay, so set up your truth table and then we'll do it. All right, so remember your first column is P, your second column is Q, and then you go through your process. So we have P or Q is what we start with. So true or true is true, true or false is true, false or true is true, false or false is false. Then we have not Q, so that's going to be everything the opposite. So now I have to do the and of these. So this will be false, true, false, false. So then we have P over here, which would be true, true, false, false. So the conditional, remember, is going to be our final answer. So what are we doing? We're combining the and from the brackets to the P. So if false, then true is true. If true, then true is true. If false, then false is true. If false, then true is true. You have to learn your outcomes for your truth tables, for your connectives. So I got all true. So what does that mean? That means that this is a valid argument. That means it's a valid argument. So I will order pizza or Chinese food. I did not order Chinese food, therefore I ordered pizza. It's a valid argument. And that's it. Okay, so now we're looking at 17. So you should see if you can pause this and rewrite 17 in symbolic form. All right, so if we do it, we should get P, then Q, Q, therefore P. Okay, so that's what it looks like. So then we also need to set it up into the form of the conditional statement. So what does that look like? Looks like premise 1 and it with premise 2, conditional P. So we want to do our truth table for this. So you should pause the video and complete the truth table for this, and then start it again when you finish to check it. So what happens here is you should have gotten an invalid argument. So when you do your truth tables, you do your if P then Q first here. And that gets us true, false, true, true. From there you have your Q, and you have to AND the Q with your outcome from your if P then Q. So you get true, false, true, false. That column has to then combine with the P using the conditional. So you end up with true, true, false, true, which gives you invalid. So if you didn't get that, you need to go through and just find your mistake, because I'm sure it was just a small error. And so that's how you translate your arguments into symbols, and then you set up your conditional statement with your argument and do a truth table to determine validity.